Okay, so we will have gy. Gy is inducing clockwise direction minus 4,500. Okay, and then we multiply by a distance of 0.6. Then we plus by by. Okay, by is going anti-clockwise, so this is equal to 0.12 or 0.06. I beg your pardon. Multiplied by by, which is equal to 0. So from here, by will be equal to 4500 times by 0.06 divided by 0.12 is equal to 2250. Okay, so this is your by. And then all you need to do is summation of forces in the y direction is equal to 0. You have ay minus by 4500 plus by 2250. The whole thing is equal to 0. Ay now equal to what? 2250 Newton. Okay. So now we know what is our ay, right? We know what's our ay. So our ay is equal to, so minus 2250 multiplied by a distance of what? Multiplied by a distance of 0.06 plus by 0.02. And then we have the gx. So gx is equal to, also we have gy, which is equal to 4500 multiplied by a distance of 0.02. You calculate this out. So 2250, 0.06 by 0.02 times by 2250 minus 180 plus by 4500 times by 4500 times by 0.02 is equal to 90. So now everything over here is equal to minus 19 Newton meter. Okay. So what does this physically mean? So over here, ay is going to generate a moment in this direction, right? That's equal to 180. Gy is going to generate a counter moment, right? And this is equal to 90 Newton. Okay, 90 Newton meter. So the overall we are going to have in this direction is 19 Newton meter. Okay, because over here we consider anti-clockwise to be positive. So now if we change the sign, 19 Newton meter is going to rotate in this direction. Okay. So immediately from here, we have found that our moment is 90 Newton meter, and we know that this is compression. And this is what? Tensile. Okay. So from here, we are going to find stress X at point H. Okay. So this will be equal to, so we know that Gx is going to induce a compression. So compression is what? 7.794 times 10 to the power 3. I have not a clue what is the cross-sectional area. Pardon me, okay? Do they come up with the cross-sectional area? 10 by 24, okay? So 0.01 multiplied by 0.024, okay? And then they will have a what? They will have a, we know that at H, which is H, okay? At H, this will be equal to 0, right? Because H, this is equal to 0. So this will be equal to minus 7.794 power 3 times minus 7.794 power 3 divided by 0.01 divided by 0.024. The stress is equal to minus 32.475 times 10 to the power 6 Pascal. Okay, so if you look at the answer, it has what? minus 32.5 at element H. And likewise, look at our numbers, exactly what? Spot on, right? No doubt we do slightly different. We did not. Wow, this is amazing. This is crazy. Can you look at this? Ours is so short, okay? Coming back to here, next, we are going to look at, okay, now we are going to look at element K. So Px over A is still going to induce a compression. Now we know our moment. Now already we know that element K is going to generate a what? A compression. You put a minus sign over there, and then you multiply by 90. The element K, the y distance is 12 times 10 to the power minus 3. And then over here, so we know that this is 24. This is 12. This is our axis of interest. So this is our width, and this is our what? Depth. So our width is equal to 0.012 multiplied by our depth, which is equal to 0.024 power 3, and the whole thing divided by 12. Okay. So this will be equal to minus 32.475, and then minus 90, 0.012 times by 0.024 power 3 divided by 12. Then we have 90 times by 12 power minus 3 divided by 8, and we have 78 times 10 to the power 6 minus by 78 point what? 125 times 10 to the power 6. So you will have 32.475 power 6. 78.125 power 6 is equal to minus 110.6 times 10 to the power 6. Let me do it again. 32.475 power 6. 78.125 power 6 is equal to 110. So it's compression. And yeah, wait, 126. Did I get 126? It's different. 11.52. Why is it 11? Please hold on. My area, what did I use? This one? Okay. So that's where I make mistake first. Okay. So this is just one mistake, but it's not enough. You get 1 pint. Is this wrong also? Wait. I need to go back to the question. Let me go back to the question. Maybe I read the question wrongly. 10 by 24. I'm sorry. So this is 10. Okay. Sorry. So this is right. So this is 0.01. This is 0.024. And then this is okay. 0.01. And then this is 0.01. Thank you so much. Both of you, 2 pints. Okay, so 90, 12 minus 3. Wait, if that's the case, yep, it's still 12 divided by 0.01 divided by 0.024 power 3 times by 12. Syntax error. So it's equal to 93.75 times 10 to the power 6. So 93.75 plus by 32.475 is equal to 126.225 times 10 to the power 6 Pascal. Okay, so this is wrong. So 126.225. 126.225. Are we clear? So different way of finding your moments, and if we take the bottom or the top, the answer will be the same. Are we clear? Okay, so don't always be fixated, oh, we have to take from the bottom, we have to take from the bottom. So if we were to do this from the bottom, okay, I will do from the bottom. If we were to do this from the bottom, what do we get? Okay, so now if we were to take from the bottom, so this is our point B, right? So we know that there's a force going up here, and that force is equal to 2250. And then we know that there's a compression going down here, and we found out that the compression is what? The compression is equal to 7.794. Bx is also equal to 7.794, right? So this is equal to 7.794 times 10 to the power 3. And then we know the distance from here to here. If we take from the bottom, the distance is equal to what? 0.04. So moment about Z, which is the most important, is equal to 2250, right? So I'm going to take positive going this direction. So 2250 multiplied by a distance of 0.04. The answer is equal to what? 2250 times by 0.04 is also equal to 90. And now it's positive because the direction is going this way. And it will be compression tensile. Are we clear? Answer is exactly the what? Same. Okay, so don't get fixated that you have to take from the bottom. Either way you take, it has to be the what? The same. Are we clear? You have to have that level of confidence. Okay, so all the questions you do, don't always follow the solution manual. Think differently. Are we clear? Okay, then you really understand the concept well. Okay, now think differently with knowing good concepts. Okay, going to do one question now on Mohr circle. Student asked me about it while I was driving, and he's not here today. Are you here? No, he's not here. It's okay. But I'm still going to do it, okay? So this question over here, okay? And it's an example question. So what do we know? Okay, so over here, we know that stress X is equal to what? 120 megapascal. We know that stress Y is equal to 70 megapascal. And we are aware that stress Z is equal to 0 megapascal because there's no stress in that direction. And we know that shear XY is equal to shear YX, and this has to be what? Positive shear. Okay. So first of all, we label this as point X. We label this as point Y. And we label this at point Z. And given to us, okay, tau max is equal to what? 80 times 10 to the power 6 megapascal. Or 80 megapascal. And we know, okay, this is the largest radius for the 3D what? Mohr circle. Now, in your term test, I will highlight to you, use 2D Mohr circle analysis, use 3D Mohr circle analysis. By the way, for the exam, I finished setting it at 4 o'clock this morning. And when I say draw 2D Mohr circle, you have to construct 2D Mohr circle. When I say construct 3D Mohr circle, you have to construct 3D Mohr circle. If you don't construct Mohr circle and get your answer, you get 0 marks. Are we clear? You have to construct Mohr circle. Right. So from here, start sketching Mohr circle. Okay. I know the solution is different, but the solution is like that because they could visualize how the Mohr circle look like. I cannot visualize yet. I have to draw Mohr circle. Okay. So this is my 0, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Normal stress. And then we have shearing stress coming in, or shear stress. Okay. So shear stress, this is our 20, 40, 60, 80. I don't think we need to go more than 80 because that's the biggest diameter of the circle. So element rotate clockwise.